Good afternoon again. Okay, nakalimutan. Okay, so what have we covered so far? Can we reset? Do you have you still have some clarifications with regards to separation variables, homogeneous? So we'll be now going to exact differential equations. So separation of variables is mainly this is our first technique and the basis for most of the solutions or procedures that we learned today, which utilizes integral and integration and of course the knowledge of differential calculus. So I do hope you have a table of uh this cheat sheet sa mga table of common integrals and differential derivatives. Next to us homogeneous coefficients, which essentially relies on the making a substitution into the differential equation to make it into a variable separable problem. It's quite there are more steps to this solution. And the third technique we'll be talking about is exact differential equations. So if wala mo yung clarifications, we shall proceed. So what is exact differential equations? We just like the previous procedure, we started off with our knowledge on variable separable equations. So a first order equation can be of the form a of x dx plus p of y dy equal to 0. But we do know that this is just a specific form. This is one instance, one example of the generic form of m of x of y dx plus n of x of y dy. So we started off simple by assuming that the coefficients of the dy terms, derivative terms, are of just one singular variable. But the more common ones actually are functions or coefficients, polynomial functions of x and y. We do not know, we do not yet have a technique for solving this one. So exact differential equations will try to give us a solution uh, for these types of equations. So these are actually more common than the previous two scenarios. What I mean by common is in terms of applications. This is more common than the previous ones, and eventually we'll go to a technique that we will use most of the time in terms of trying to solve engineering problems. So dili pa ni siya ang pinaka-common technique na inyong magamit. So we're trying slowly getting to that point by learning how to solve differential equations at this stage as of now. Okay, so with that out of the way, the main the the solution, this technique that starts off with an assumption that there exists a function f of x and y, where if you differentiate the function, diba? If this is arbitrary function, we don't know exactly what this is, but if we differentiate it, we will get m of dx plus n dy. So we're trying to guess a solution based on this assumption. Now, for this to be true, it means that f of x and y should be also equivalent to a constant. Diba? Naamagid na siya. This is an assumption. But for us to make a function f of x a solution to a differential equation, we must find a way such that f of x and y is equal to 0, not to a constant. Sorry, the derivative of f of x and y should also be equal to 0, so that we can write this to be, so if we take for a moment this one, focus on this one, this is equal to a differential equation, a first order differential equation. But at the same time, we also try to make this general observation, or sorry, general assumption. Then we will guess a function of f that can fit this equation. So duha ka po conditions ang ato ang gitan-aw at the same time. So which means that the derivative of f must also be equal to 0. So where do we go next? So if we have d of f equal to m dx plus n dy, ako already ning shortcut ang m of n para madali ra masuwat. So m and n are still functions of x and y, both x and y. But if we do, and at the same time, if we make this assumption, this means that for this to be true, the partial derivative of f with respect to x is equal to this one. Partial derivative of f is equal to n with respect to y. So this is also true from calculus. If we want to this is also true if we assume that this is equal to 0 based on our previous uh, assumptions to find a solution f. So that means this is a consequence of what we assume to be a property of of an answer that we are looking for. This means that the partial derivative of f with respect to x is equal to m, and the partial derivative of f with respect to y is equal to n. Now, with these two equations, we can further show that if we take the partial derivative of m with respect to x, with the y, this will be equal to the second partial derivative of f with respect to both x and y. And if we also differentiate the other equation with respect to x, we have the partial derivative of f. Na may partial derivatives, di ba? Okay. With respect to palitin siya, x and y. What we can see here is that these two, if we do these derivatives, are actually equal. So the partial derivative of m with respect to y is equal to the partial derivative of n with respect to x for an exact differential equation. This is the condition that we are looking for. So this becomes our condition for applying the actual solution to this technique. I guess if magbalik-balik ko kung nasa time, so I'll go directly to an example. So this is the basis there for exact equations. This solution can only be applicable for a differential equation. In general, it looks like this. But if we use this to check if the equation is exact, that means we can proceed with the following solution to solve that differential equation. So the main thing that differentiates this from the previous examples is that we are not limited to the order of the differential. Sorry, the coefficient of the derivative terms. We can solve this as long as this is correct. So we can now have uh, non-homogeneous coefficients, but we can still solve them. So for example, we look at 3 3x xy minus 2 dx plus x cubed plus 2y dy equal to 0. So this is an equation that cannot be solved using homogeneous coefficients because we have a term here that is just a first order term. So dili to magamit ang atong previous solution. So the first thing we do is to check if we can use the succeeding solution is to perform this operation. We take m, which is the coefficient of dx. This is m. The coefficient of dy is n. So we take the partial derivative of m with respect to y. So this is partial derivative of 3x squared y minus 6x. So the answer is we treat x as a constant. So factor out sa tanan. This becomes 3x squared. So derivative of y over dy equal to 1. The derivative of a constant is equal to 0. For partial derivative of n with respect to x, so we have the partial derivative of x squared plus 2y. So the only term that can actually be differentiated is this one. Since 2y is treated as a constant, that term will automatically be equal to 0. And you have 3x squared. So if the result of these two are the same, which in this case, what we have, obviously this is an example, this means this is an exact DE. The next step will be the start of our solution. So remember that we assumed that the derivative of f is equal to, as long as we have, this is our this is the solution we are looking for, f. with respect to x. Since we know that this is an exact equation, this means exact DE m is equal to this this equation. So what we do know is this one, the value of m, which was 3x squared y minus 2x minus 6x there minus 6x. And at the same time, just to be complete, we have with respect to y is equal to n equal to uh, x cubed plus 2y. What we are looking at actually is the solution to this. We can see that if we just figure out what f is, we have a solution. By the way, our assumption was that f is equal to an arbitrary constant. And if we differentiate f with respect to x or y, it will be equal to the coefficient of our given differential equation. So this is what we are looking at now. So this is where you have to make a choice. We can get the solution either from this equation, let's call this A, and this equation B. So you can choose this one. At what point you want to switch over, depende sa unsa imong ganahan. So let's go with F. If we integrate this side, let's go with uh, equation A. So if we have partial derivative of f with respect to x equal to 3x squared y minus 6x, if we cross multiply to the right and integrate, makancel out niya siya. So that means we have a possible solution in the form of the integral to the right side. So we will, this becomes y, 3y, x squared x minus 6 integral of x of x. F, so this becomes 3. Saan siya? What's the integral? This becomes x. What's again? X to the n plus 1 over n. Sakto ba? This will become x cubed over 3 minus, yeah. So this becomes 6 x squared over 2 plus we have, since we are doing a partial integral, the consequence of one of the consequences is that our constant of the integration is not purely a constant alone. It is a function now that's possibly in terms of y. Since we in a partial differential, we are treating y as a constant. So it is absolutely possible that the result of the integration will generate not just a constant value, but a term or a polynomial of the variable y because of the integration of the partial differential that we just did. So this is a solution now. We can simplify this f equal to y x cubed minus 3x squared plus e y.
Sir.
Yes.
Makaka-record, sir.
Nag-record ko sa OBS, dili sa Google Meet.
Ay, okay, sir.
Ah,
Sige, sir. Thank you, sir. Sir.
yes. So naa na tay f Now, notice that we took this equation based on equation A. We have another basis to solve for f. So we have there are two equations that are supposedly equal, which is equation B. We need a way to solve for to determine what y is. So the other equation that we can rely on is equation B. Asa di ay ang t of y here? If we integrate the this equation just like we did here, but instead of uh show this in a different slide. If we have derivative of f with respect to y equal to x cubed plus 2y, if we do the same thing for the previous one, was to respect to y, we integrate both sides. So we will get sep. Na de mas dali. Uh, okay, while naa na lang dire. Okay, so we now have this. This is part of our solution. We have f. This is a potential solution to the given differential equation. What we need to know now is what is dy. Um, the assumption for exactness is that these two partial derivatives are equal to each other. But we know that f, this one, if we differentiate this with respect to x, uh, differentiate this with respect to y, this will be equal to n here, or this will be equal to the left side or right side. So if we take the partial derivative of f, we know f as katong previous nga equation, y x cubed minus 3x squared plus ty. About ani no? If we differentiate this again with respect to y, this should be equal to this polynomial right here. Meaning if we do this operation, the result of this is equal to 3x. What should be equal to that? 3x ba to? X cubed plus 2y. X cubed plus 2y. Equal ni silang duha. This is what we will use to solve for the differential equation. So, treating x as a constant, the partial derivative of f with respect to y, this one is derivative of y squared, no? X cubed, oh no, cancel out, dy mo. Mawa ang y. And since this is a constant, derivative of a constant is 0, we now have t prime of y. Since we assume this to be a function, so tabla ni siya t differentiated with respect to y. Using this and this, we can solve for t prime of y. The equation now becomes, if we equate these two polynomials together, we have x cubed plus t prime of y equal to x cubed plus 2y. Uh, the only thing we have to do here is just cancel out. We can simplify this. So t prime of y is equal to 2y. To cancel out y, this means we have to integrate this again with respect to y. So t of y is equal to y squared. So we now have t of y, and if we go back to our the result of equation A, pwede na nato ma-list done with an actual term. Batian ako pagka layout eh. So that means going back, f is equal to x cubed y minus 3x squared plus y squared. And by simply equating this equal to an arbitrary constant, since at the very beginning we assume that there exists an f, a function f, which is equal to c. So we did several integrations, and we can introduce the result of the arbitrary constants simply in this way. This is now the solution to the exact differential equation given in this example. Any questions so far? Ang nakalingaw anino, if you think about this, the solution is actually found in the given itself. We are just merely making assumptions and making a condition to to make those assumptions valid. So that's exact DE. So making sure that this differential equation is exact, and then from the coefficients themselves, m and n, we can get a possible solution to our differential equation. So of course, you can rewrite this in a different form. Pwede ra gid ninyo i-kuan. Sorry, this is y squared. Okay, supposedly, the solution is a function of x or y, depending. Yeah, nakalimot ko sa what. So if you have notes, no, which I do highly recommend that you do follow along with the solutions, you can test this solution by switching up your options at this stage. So instead of using equation A to get F, you can use equation B to get F, but be careful that this one will result in, so may atong gamiton instead of T, Q of x na ni siya. This is the arbitrary constant introduced by doing the integral of a partial derivative. So dira ra ni siya. So if nag-partial derivative ka with respect to y, the arbitrary constant will be possibly a function in terms of x. Of course, let's go with another example, and then one more just to be um okay ra ang ako ang agi. Is it too big or too small? Pwede man siguro nako pagamyan, no? Kay since you're looking at the screen or doon mo sa screen. So this is how I usually manage the space on a whiteboard. Dili kay nako gamayon kay depende if kakita ang mga estudyante ba. I can either make this smaller or keep it as is. Mora na ang option. So unsa man pagamyan ako or dili ko magsigig tab. Sige sige. So let's look at another example. Okay, again, let's take always check if so far you've already learned variable separable, homogeneous coefficients. Always check if a given problem can actually be solved with a prior technique or procedure. So we can, of course, this is not variable separable. We can do a mental quick check if this is a problem of homogeneous coefficients. So this is third order term, second order, first order term. So automatic. We cannot solve this equation using the previous two techniques. So we have to check if we can use the exact equations in solution. So remember this, we assume to be m. The coefficient of dy, we assume to be n. So if we take the check is if with respect to y equal to the partial derivative of n with respect to x. So if this is true, that means the equations is exact and we can proceed with the technique. So, mamata-mata na ba ba? Hmm. So, m with respect to y, this is a constant, so makancel out ni siya. The first term is a constant, makancel out ni siya. X is treated as a constant, so this becomes minus 3x y cubed minus 4y squared. That's for partial derivative of m. Next is the partial derivative of n with respect to x. So this should be x now. So y is constant, so this is y 3x squared, 3x cubed plus, ay, so, okay, po, may do not forget to incorporate the negative term there, especially if you're given this one, because the general format of this is supposed to be m dx plus n dy. So dapat ma-incorporate nimo ang negative sa into the coefficient n. So that means we should work with minus x squared y minus 2x uh, prior to differentiation. So this is y is a constant, so minus y 2x cubed, and this should be minus 2. Dili siya exact lagi. Asa ko sa'yo? Ano ni? Balik-balik. Clark Mozart. 2 unta. Lagi ba? Tinamay ra ko. Let's do this step by step. Kasi katulo siguro. Maano. So the partial derivative of m with respect to y equals 2x cubed minus x y squared minus 2y plus 3. So we should differentiate this with respect to y. this is a constant. Minimum ni siya ng 0 minus x. Ay, sayop. I mixed integrals and again. So the second term, power, i-bring down na to and then rewrite it with n minus 1, di ba? Ang integral mo ang answer kay 2 plus 1, n plus 1. Okay, so this should be minus x to y only. Then this one, minus 2, since ma-cancel out in dy, p is a constant. So this is the result. This cleared, minus 2x minus 2. And if we do partial derivative of n with respect to x, minus x squared, y minus 2x, and with respect to x. So y is a constant, minus y. The integral, the derivative of x squared is 2x. Cancel out, so minus 2. This becomes minus 2x, y minus 2. So it is an exact equation. Thank you, Clark. It's the same, ano? So the next step is we present our options. F can be found from the coefficients of both terms. So f, partial derivative of f with respect to x is equal to the given 2x cubed minus xy squared minus 2y plus 3. Or we can go with f with respect to y equal to minus x squared y minus 2x. So again, this is this is n. From the given, this is n. And this is m. So na kayo options kung sa imuhang ganahan. From the previous example, we were integrating with respect to x. And mas mubo sa gid ni sila. So let's go with the equation with this one. So ganito. So I used equation A. This one is EQNB. This one is EQNA. Yeah, so we'll go with equation B. That means f, the partial derivative of f is equal to minus x squared y, partial derivative of y, minus 2x, partial derivative of y. You can integrate both sides. This way so that we have our potential solution f. X here is a constant, so we get minus x squared y squared over 2 minus 2xy. And our arbitrary constant is u of x. So kung unsa imuhang integration with respect to the other variable is your arbitrary constant. For the result of the integral of a partial derivative. And from here, we differentiate this again, but instead of we differentiate this with respect to x, so that ma-equate ni nato siya to this equation. Minus y squared over 2 ang constant. So the derivative of x becomes minus y squared over 2. Constant siya. The derivative of x squared is 2x minus, so 2y is a constant. The derivative of x is equal to 1, so this becomes minus 2y, and this becomes q prime of, we don't know what q prime of x is. We can solve out, ultimately we want to know what q of x is, but in order to do that, we have to make this partial, we need to make this partial differential so that we can equate, so we now have two terms equal to this partial derivative. So pwede na natong equate ang kaning nga term sa kaning nga term. So let's do that. Let's have, sigo ka pa kani, minus, let's try, minus y squared minus xy squared, ma-cancel out ang 2, minus 2y plus u prime of x equal to, it's a very long term, minus 2y plus 3. Cancel out minus 2y because they're present on both sides of the equation. We also have x squared, minus x squared, minus xy squared. So this, we are left with x equal to 2x cubed plus 3. In order to get qx, we have to integrate everything with respect to x. Remember that q prime of x is just q of x with respect to x. Cross multiply to the right and then integrate. So the integral is, integral now, so this is 2 over 4 x to the 4 plus 3x. Pwede na ni nato ang substitute balik dire. So we now have f is equal to minus x squared y squared over 2 minus 2xy plus 1 half x to the 4th plus 3x. I don't think we can simplify this further. This means our answer is x to the 4th over 2 minus x squared y squared over 2 minus 2xy plus 3x equal to C. If di ka ganahan o half dire, you can multiply everything by 2. So if you look at the textbook, that's what, that's the last solution, a possible solution. So it's the same anyway. Any questions? Clarification so far? Ah, midterm. Mag-pre-med pa ta o Chia. Schedule pra ko. Um, we can have an exam after we finish the next subtopic. Dugay ba ako naka-start ba? I think we can catch up sa Bernoulli's equations after Unit 2. Unit 3 is quite, no, Unit 4 is shorter. I will just, oh, before I discuss the Uchiha's concern, any questions, Diri? Or do I do one more exercise and then question and answer and then uh, tackle the issue? Tao asas tao. Ah, someone by one more exercise. Oh, sorry, one more example. How are you with the integrals of, say, trigonometric functions? Do you like integrals of trigonometric functions? Silence means yes. Integral sa cotangent is sa gani cotangent. Basta ako palumot. Sige, sige. Wow. Always check for exactness. So partial derivative. So our example, we have quantity 2x y minus 3 times x squared, um, close parenthesis dx, and then open parenthesis x squared plus y, close parenthesis dy equal to 0. We check for exactness. We're calling that the partial derivative of n with respect to y should be equal to the partial derivative of n with respect to x. Yeah. So we partially 2xy minus 3x squared back to y should be equal to 2x, and then partial derivative of x squared plus y with respect to x. They should be the same. Y is a constant, so we have 2x for the first term. So yeah, this is an exact differential equation. We can then proceed with the solution. What happens if dili siya exact? You use another method to solve the problem. Be it homogeneous coefficients, or if it's simply variable separable, then that's the technique that you should be using. So We are now presented with an option. We know that the partial derivative of f with respect to x is equal to 2xy minus 3x squared. And the partial derivative of f with respect to y is equal to x squared plus y. Yeah? Yes. Asa inyong ganahan? Solve na to. In terms of complexity sa coefficients, no? They're relatively the same. Two terms. Actually, mas simple gamay. Partial derivative of f with respect to y. So let's go with that one. So, kani ang winner. So, f, the derivative of f is equal to x squared plus the derivative of y plus y plus the derivative of y. We integrate f is the squared integral of d1 plus the integral of y or y prime. Ito kami dito. So x squared y plus y squared over 2 plus u of solve for q of x, and having our answer, we need to differentiate f with respect to x. So this becomes y 2x plus derivative of a constant is 0 u prime of x. So partial derivative of f with respect to x is equal to this term, this expression. So here, so y 2x, sorry, 2xy plus u prime of x is equal to 2xy minus 3x squared. Cancel this since they are both on uh, they are in both sides of the equation. To be clear, q of x over derivative of x and minus 3x squared. So to get q of x, we have to integrate minus 3x squared. That's all. D. So dt of x, nabati akong agi. Then integrate. So q of x is equal to so lang ito, minus x cubed. We now have our q of x, so we can substitute it to back here. So f is equal to x squared y plus y squared over 2 plus no, plus minus x cubed. Since at the start the technique actually assumes that f is equal to an arbitrary constant c, so this the final answer being 2 minus x cubed equal to c. Just to check if tinuod ang gisulti sa textbook, let's try to solve this again. But we take a partial derivative of f 2x y y sorry x ni. So we're using uh, x squared. So f is the integral uh, 2y integral of x dx. Perceive d implying that this is a partial minus 3 integral of x squared derivative of f. F is equal to y x squared pi x squared minus x cubed plus t of y. We need to take the partial derivative of this again in terms of y. So we get x squared and 0 becomes t prime of y. So we can equate this one x squared plus t prime of y with the coefficient of our dy term x squared plus y. Cancel out x squared. So this leaves partial derivative of t with respect to y equal to y. This means t of y equal to y integrating. So t of y is equal to y squared over 2. We substitute this here. We have f is equal to x squared y minus x cubed plus y squared over 2. And since these should be also equal to f, so x squared. Uh, by the way, if you do write your coefficients, no, try to keep it Pedra, I think the if you haven't noticed yet, but most of the textbooks try to arrange the coefficients, oh sorry, the variables alphabetically, and then the traditional one is descending powers, descending degree of the terms. So the correct way, so according to that, this should be minus x cubed plus x squared y plus y squared over 2 equal to c. So this is one of the conventions that is generally followed. And if you take a look, this one is equal to this one. Depends on you. As long as you follow the procedure, you can get the solution to an exact differential equation. Verification, concern, violent reaction. Tao may sa violent reaction. Tuwa lang sa ilahang doon. Mask ug face shield lang daw ng 2 meters apart na pwede ra mo mag physical concerns. Yeah, so that's the differential equation. Webcam's on though, guys. Ah, now my concern. Question. Ako kam sir wa madetect. Hmm. Depends on your laptop. If you're working on a laptop, some laptops have proprietary software, mga control center kunuhan, mga software disable ang camera. So maybe you can look at that. Norman, I guess maybe you should look into buying, even if it's just a kung ano, simple webcam. Kuha na siguro mo. Kasi mo, um, yan, alam ko i-chika after this afternoon. Actually, lisod sa gid ipalit. I was actually thinking of looking for a webcam before I decided on buying a digital tablet. Kay na ako I have a whiteboard. I was planning to just set up a webcam and then making it point to the whiteboard, and that's where we do the class. Since walay webcam gyud sa katunga time, order na lang gyud ko tablet online. I guess it's okay solution. Hmm. Wala ra, okay ra mo. Nanatay tulo ka buok techniques, no? One more, and then I think we can go for an exam. Wala ra may concerns. I will end the recording. Questions, clarifications. Di na lang ko mangutana kung naka-follow ba mo or nakasagot. Ta ako alam, habang may concerns. Practice solving na ta. Sige, I'll end the recording.